We are going to start introducing you to the unit circle today, and we're going to do that through a quick exploration and going through different parts. So on this part, it says fill in the missing blanks and use correct notation and label the quadrants and the X and Y values. So that's what we're going to do real quick on this circle here. It starts at 0 degrees. We know that this one up here would be 90 degrees. This is 180. And then in the bottom here, we have 270. Now between, and then the final one is 360 degrees here. Now for our middle term there, we know between 0 and 90, right through the middle would be 45 degrees. And then we would add 45 to the 90 to get 135, because that's what would be between the 90 and the 180. And then over here, we would get 225 degrees. So we've gone ahead and labeled our degrees. So we've labeled all the degrees of our circle that we've put on the coordinate plane here. So now let's label our quadrants. Our first quadrant is right here. That's this section. Our second quadrant would be over here. Our third quadrant is this bottom one. And our fourth quadrant is this one here. It goes in a counterclockwise. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then our x-axis is this one here. And our y-axis is this one. When we're working counterclockwise like this, that gives us our positive degrees. Now, if we worked clockwise, we would work negative. So if we start here at the 0 degrees and we work clockwise, it would be considered a negative. So this would be negative 45 degrees, negative 90 degrees, negative 135, that's negative 180, negative 225, and negative 270. That does not change our quadrant, so this is still quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, as we continue on that, we're going to talk about a couple of terms that we need to know and some more information, and then we'll go back to those circles. So it says an angle is determined by rotating a ray about its endpoint. The starting position of the ray is called the initial side. And the position after the rotation is called the terminal side. So we start that at the positive x. So we start this at the positive x and we move counterclockwise to look like this. That would be a positive angle. Again, if we start at the negative, if we start at that positive x value and we move clockwise, then that is a negative angle. And so that starting point is that x-axis right there. That is called the initial side. And then that ending part right here, that's the terminal side. So the picture kind of helps to see what those terms are. So my initial side is where I start the angle, and then the terminal side is where I end that angle. All right, it says we will draw our angles in standard position, which is this. Angles may be positive or negative. Positive angles are generated by counterclock rotation from the positive x-axis, like circle 1, and negative angles by clockwise rotation from the positive x-axis, like circle 2. Angles are labeled with lowercase Greek letters. So you have to know these letters because that's what we'll label our angles with. Alpha is the one that looks kind of like that little sideways fish there. Beta is the one that looks like with a B with the longer line. Theta is the oval with the line through the middle, and they're all capital letters. Determine the quadrant in which the terminal side of theta lies and sketch the angle in a positive position, standard position. So if we think about 110, we said this is 90 degrees right here, and this is 180. So you should know that 110 would end up in this second quadrant. And so that is my angle there, and we'll label that as theta. That's the one that we use most often, is theta. So there we go. And so that lands in quadrant 2. For 400, that means we started here. 360 is one whole rotation. And so 40 more would give me 400. So that's going to be in quadrant 1. And we label that going all the way around and then back to our angle here. Again, we'll call that theta, and that's in quadrant 1. For negative 150, we said this is 90. Sorry, I forgot to write the 360 there. This is negative 90. This is negative 180. And so we know that negative 150 would have to land between these two here. And so we start the angle here at the x-axis on the positive side, and it moves this way, and that is our theta. That would be in quadrant 3. All right, two angles that have the same initial and terminal sides are called coterminal. So if they have the same initial and terminal sides, they're called coterminal. Using circle 1 and circle 2 list 3 pairs of angles that are coterminal. So we're going to look at those just so that you can see some examples of that. So if we're just looking at these two circles here, we can see that 90 was this one right here on the positive, and then on the negative, it was negative 270. So 90 and negative 270 are considered coterminal because they both have the same x-axis initial point here, and they have the same terminal side, which is this side here. The same would be true for 225 and negative 135. They both have this initial side and then this terminal side. So that's what coterminal is called. All right, we're going to keep talking about these circles here. It tells us that the circle has a radius of 1 unit. That's why we call it the unit circle, because it's only 1 unit with a radius. The radius is 1 unit. So it tells us a circumference of a circle is 2 pi r. So if the radius is 1, what is the circumference of the circle? Well, we would plug in 1 for the radius, and so it would be 2 pi. So it tells us to go back to our circle and label that on circle 1. So we're going to talk about that on circle 1 now. All right, so it told us to go back and label it here on circle 1. The circumference of this circle with a radius of 1, so our radius was 1, was 2 pi. So that means from there all the way around was 2 pi. So 360 has to be the same thing as 2 pi. So taking that circumference that we found, what would be the circumference at 180? Well, that would be half of the circle. So it would be from here to here. And so half of 2 pi is pi. So 180 has to be the same thing as pi there. All right, now if we think about these other ones here, so we're going to break it down a little bit further. So if this is 2 pi and this is pi right here, and let's break it down then now to the 90 and the 270. That would break our circle into 4 parts, 1, 2, 3, and 4. And so if this is pi, if half is pi, then this is going to be pi over 4. I'm sorry, pi over 2. Just broke that into 2 parts. Sorry about that. And so then here we would have 1 quarter, 2 quarters, and 3 quarters. So this would be 3 pi over 4 over 2. Sorry about that. I'm writing down the wrong number. So now we've broken down the 90 degree, the 180, the 270, and the 360. So if we want to break it down even further, we would break these here. So if we're looking at pi is the half of this, then this one would be a quarter of the pi. So this would be pi over 4. And then this one here, it would be 3 pi's over 4, because we've got 1 section, 2 sections, 3 sections, and 4 sections. So this would be 3 of those 4 sections, making this one 5 of those 4 sections. And then this one over here, seven pi over 4. All right, I'm going to continue to fill this out here. It was stuff that we were talking about as we solved the circle. It says taking the circumference you found above, what would be the circumference of 180? And we said that would be pi, because that would be half of the circle. What would be the circumference of 90? And so that was pi over 2, because that was half of this 180. And then the 270, we said that was 3 pi over 2. And for 45, that was pi over 4. So we've labeled those on the circle. As we continue, it tells us mathematicians have another way to represent the measure of an angle. This is called a radian measure. That's important. We have a formula to convert between degree and radian measures. What we just did there that we labeled on the circle was write our radian measures. Sometimes you'll see angles measured in degrees, and sometimes you'll see them measured in radians. A radian is basically when the radius and the arc length are equal to each other. That's why we end up with those pi measurements. Because we know the entire circle is 2 pi, we're looking for those arc lengths to be the same. And so that's where we get those radians. You can easily convert from degrees to radians and radians to degrees. You will have to be able to do that. So to convert from a degree to a radian, we multiply the degree measure by pi over 180. To change it from a radian to a degree, we multiply the radian measure by 180 over pi. So notice those are both the same. They're just flipped over. So we've got the pi on the top when we're converting from a degree to a radian, and the pi on the bottom when we are converting from a radian to a degree. It tells us here, convert the following angles from degree to radian. So when it does not have a pi here, and it's a degree, we want to use this top one. We want to multiply 60 times pi over 180. You remember when you're multiplying fractions, 60 is over 1, and we multiply straight across. And so we get 60 pi over 180. That's the reason why that formula is there, because now we end up with a pi in our number there. We can reduce 60 over 180, reduces to pi over 3. So to convert 320, we take the 320 and multiply it times pi over 180. That's what you will do always to convert from degree to radian. We multiply across and we get 320 pi over 180, which reduces to 16 pi over 9. That would be the radians for 320 degrees. Now to convert the angles from radian measure to degree, that is where we take it and we multiply times 180 over pi. Notice that 1 is in the numerator, 1 is in the denominator. So the pi's are going to cancel out. And so we end up with 180 over 6, which is 30 degrees. So we converted it from radians to degrees. We do the same thing here for 5 pi over 3. We multiply that times 180 over pi. The pi's will cancel again. And then we multiply across, which is 900 over 3. And that gives us 300 degrees. So that was our conversion there. Just like we did with the degrees, we can do the same thing with our radians to determine which quadrant it is in. So right here, we want to determine the quadrant for 2 pi over 3. And so you want to think about that is 2/3 pi. And we know that this right here is pi, and this is pi halves. So 2/3 pi would be here. And so that is our quadrant 2. For this next one, we're doing pi over 6. And so we know this is pi over 2, and this is 0. Pi over 6 would fall in between those. So that would be in quadrant 1. For negative 7 pi over 4, remember we're going to go clockwise for negative. This is negative pi here. This is negative 3 pi over 2. Negative 2 pi. Negative pi over 2. And so we're looking for where negative 7 pi over 4. We know that 4 goes into 7 one time, so we have at least 1 pi that's going to bring it here. And then we're left with 3/4 of a pi, which is going to take us to this side here. And so it went this way. So that would be in quadrant 1 as well. All right, give 2 angles, one positive and one negative, that are coterminal. Remember, coterminal means that they land right on top of each other. So if we've got 36 degrees, in order for it to land, I'm going to sketch a picture just so you can see it. There's 36 degrees. In order for it to have this same angle, we can go all the way around plus the 36, and that's going to give me another coterminal one. So to get that one, we would do 36 plus 360, which is all the way around. That gives us 396 degrees. That's a positive coterminal. For a negative, we would want to go from this side. And so in that case, it'd be the 36 minus 360, which gives us a negative 324. All right, for 570, I'm going to draw my initial one here. It is going to go all the way around and then go again up to here. So there's my 570. In this case, I can take that 570 and subtract the 360 so that we can figure out what's here. And so that would be 210 degrees. Would give me the same one. It just wouldn't go all the way around. It would just be 1. And so to figure out the other one, the negative one here, that one would be negative 150. We take this 360 and the difference there would be the negative 150. We could do the same thing for our radians. So 5 pi over 4. We draw our initial one and we want to find which ones are in this same spot. And so I would take 5 pi over 4 and subtract the 2 pi. And that's going to give me my negative angle right here. 2 pi is all the way around. So if I take this and subtract that 2 pi over 4, we get negative 3 pi over 4. There's my negative coterminal angle. And if I do 5 pi over 4 plus 2 pi, I get 13 pi over 4. That would be my positive one. That's when it went all the way around and then again. So 2 pi's all the way around and then the 5 pi over 4. For those of you that struggle a little bit with fractions and you can't figure out where this came from, we did 5/4 minus 2. Remember, that's over 1. And in order to subtract fractions, you have to get a common denominator. So this would be 5 over 4 minus 8 over 4. To get a common denominator, I need to multiply this times 4, so I need to multiply the top times 4. And then when we subtract them, that is negative 3 over 4. So that's where we got this negative 3 pi over 4. All right, that was our first introduction to unit circle. We'll keep going with this on our next one.